Kia ora, kia ora, kia ora. Coming into the middle section of our day together, we have Mark just getting set up now, Matthew Banks from AUT, and then Mark returning, so a bit of a back and forth. But just while we're getting set up, a small message about lunch. Lunch today is sponsored by the lovely Irma and Bob Birchall. They don't know yet that this is the lunch that they sponsored. So we thought we'd take a little bit of a Kiwi-Aussie battle for lunch today. So we have some meat pies on the menu. I know everyone's not laughing because not everyone eats meat. That's fine. I'll accommodate you in a moment. But so we have a steak and cheese pie, which is what you can buy in the bakery for like $6 in a little paper bag. And we've got some Wattie's tomato sauce out there, which is New Zealand's preferred tomato sauce usually. And also some kai tai whae that Chris wanted to, I don't know, just if you like hot sauce, he wanted you to have some. Or maybe he wanted to trick you, I'm not sure. But he's got some kai tai whae there for you too. And the other item on the lunch menu is the pavlova, which the Australia and New Zealand like to fight over. So Emma was just saying we're doing a Kiwi-Aussie lunch, and it's sponsored by yourselves. And so the pavlova is made, only has inside of it egg and sugar, and it's this crunchy, yummy dessert that often we have at Christmas, and has cream and fruit. But we kept the cream off for people who can't have dairy, off a few, and and there are some vegan and vegetarian pies also. And then, so for those who are gluten-free, the pie world does not accommodate you well, and meet me at lunch and I'll go and get you sushi. So just come with me. That's really only a couple of you. So that is the lunch messages, is the Kiwi-Aussie pie pavlova off. And I'll pass you over to Mark. So Mark, I'm going to tell you a little bit about him first. It's from Austria. And so Mark Hofstetter, born and living in Austria, co-founder of HKS3 or Kohacon25 Support EU. So he went and got a master's in chemistry and just decided to work in IT anyway, and has been working in Pearl for 30 years. So one of those old school Pearl clubs, member of the old school Pearl club, and been working with Koha for around 5 years. And he's got a bit of a thing for databases. And I'm really excited about this next talk because there's just no one it won't be relevant to, because it's about data and SQL tables. So how could you possibly not need to know about that if you have a database? So thank you, Mark.
Thanks a lot for the kind introduction. Just have to look whether everything is set up and working, because as always, it looks good. So, hello, my name is Mark Hofstetter. I'm the H in HKS3, so my other colleagues are in Austria and keeping the house. If you like our logo, I did some stickers in the usual Koha rectangular format, so don't hesitate to get them and put them wherever you like, but ask first. So, what I'm talking about is, as the title says, it's normalizing MARC 2221 data to database tables. The moment of conception of this idea was this year in Marseille, and I started working on it. And I did most of the database part. Tadeusz, a colleague of ours, fleshed it out. So it's a fairly equal co-production between the two of us. And I'm going to lead you through it, what the basic ideas are, and what you can do with it. So, all of us know that the MARC XML data is stored in a database blob. This is, if it's going to stay this way, this is going to be the same for BibFrame, which I consider very clumsy in a way, because you can't query it properly. So if you have just one blob to query, that's okay. But if you want to join it, or if you want to aggregate data, it's getting slow and clumsy and near to impossible to handle it. So that was my main objective. So now, whenever you insert or change a MARC XML record, we use in Koha hooks to fill database tables which can be queried, as all of us know, with SQL. So the solutions so far was Kohacon mapping. Everybody knows this. It's just, you can have a few fields written to the database, but it's some sort of quarter-way solution at least, because it's just, you just have a limited number of fields, and they carry a name, so you can misuse them, but it's still clumsy. And when it's really getting unpractical, if you have multiple fields, like in keywords, if you have 650 fields, they got serialized or weirdly denormalized, as I've written. Another solution we use a lot is some sort of a crutch, is like using MySQL generated tables, fields rather. So if you can extract, all of us at Nauseam wrote extract value queries, and this one sort of normalizes a selected field into a JSON field, which sort of works, but is still not nice. So that's about the state as we are. So my main objectives were create a reversible one-to-one, to use the mathematical term, bijective mapping of MarkXML to SQL tables, which means, in the end, that with this plugin you are able to losslessly convert MarkXML to SQL table, SQL data, and convert it back. So if you don't change anything in the database and you convert the tables back to MarkXML, they are byte same rather. Okay? So it works both ways, which requires to maintain the order of fields and subfields, because that carries meaning in MarkXML. So this is sort of the ERM, the entity relationship model. I'll just show it to you in the browser because it's larger here. Getting old is nothing for the faint of heart. You have to accept me. So how are we doing it? We're getting from the Biblio table, Biblio and the auth header table. So here are our Biblio metadata, where the XML is stored for Biblios, and the auth header table, where the XML is stored for authorities. We link it to a table called records, where we have a type. So it's either Biblio or authority. We're linking to either a Biblio number or an auth ID. So either you can go, if you query it, you just can go by the type, or you say where the Biblio number is set, it has to be a Biblio. If the auth ID is set, then it has to be an authority. So which links to the fields, which are a field like 245 or 650 or whatever, which has many subfields. And as you see, this one has a tag, this one has a code. Okay? So this is straightforward. When do we fill it? We have to fill it initially. So if you install the plugin, so it's wrong either way. So I have to take on my glasses. So if you install the plugin, a package is available for it. You can go to Tools, and we have several jobs. The first job you have to run once is normalize all records. So to initially fill the SQL tables, you can do either records and authorities, or normalize all except authorities to the other possible. This one verifies whether the conversion works both ways. So we're converting from Mark to SQL, and this verify job checks, okay, if I'm converting back, does the MarkXML look the same as the initial one? And we're coming to the other ones soonish. So now, having this plugin installed, the data normalized, you can query the data as you always wanted it to. Admit it. Confess. It looks like this. Select where select tag, code, whatever, indicators where biblionumber is whatever, or contains. We're going to look into some specialized queries afterward. But this is, when I first started working with Koha, I just sort of typed something like that and hoped that it's going to work. It didn't. So that's where we're going. Whenever a record changes, the changes are written to the database. And when the plugin is first installed, you have to normalize all the existing records, which may take a while if you have a lot of records, starting from a few hours to a few days. But this doesn't really matter because it has only to happen once. And in between, you can work normally because all the changes are recorded. Space considerations. How much space does it take up? Not surprisingly, about as much as bibliometadata or the auth header table. Yeah, that's clear. And whenever people complain, that's so much disk space, choose your career wisely. If you don't want data, you shouldn't have become a database. So it's, no, it's so much space. Yeah, go away. So, a short interlude. Thanks to the organizers, Chris. Thanks. Thanks to the always friendly people of New Zealand, and special thanks going to Katrin, who carried me through the Koha journey. We had great fun the last 2 weeks together doing SQL. I don't know what you... whatever three-letter word came to your minds, we did SQL. So let's have a look how this actually is looking. So I prepared something. Here we have the full-blown query, which links all the tables together. So it joins the records table. It has to be somewhere, yeah. It's the records table, joins them with the fields, joins them with the subfields, and takes it where with a certain biblionumber. So we can execute this one a bit too less, maybe. So that's exactly what we want to look at. So that's, I did it. I think it's a good idea. So you can use the full, What we also did is, because it's somewhat inconvenient always to do this linking, we did a few, which basically does the same as you've seen before. No, I'm not copying it. Select tag, or just biblionumber, tag code from where biblionumber. And as long as I'm going to work with Koha, I will never be able to write biblionumber on the first attempt. So this should work. Value would be great as well. So let's do page lesson here. So it looks like we would expect, and it's far simpler than to do the joins. So you forget about the joins; those are the underlying tables. But mostly you are going to work with this view, which simplifies life for you. Okay. What else have you got here? What do I want to show you here? You can do, for an example, you can do a regex search, which would be hard. So give me all the books where 245A contain the word Perl. So it's regex search. Search. .SQL. You get all the books having Perl in the title. That would have been difficult just with extract value stuff. when things get tough in there, I have to thank Catherine. She did this SQL. So we want to find duplicate 650 keywords, which is something, I guess, for many librarians may be of importance, or something compared to this, which is really not hard, but cumbersome, doing it just with the SQL. So what are we doing? We are selecting, we are concatenating all the codes of the 650 fields, A, X, Y, Z, 2, and V. Group them, and we just want to have those having the same keyword, 650 keyword at least twice. And the performance, I mean, this is a small test data set, but the performance is also very good on much larger databases, because all the things are indexed, it works seamlessly. So even if you have 1 million records in there, it works quickly because it's indexed. So let's see. Oh, we seem to have one Biblo number having a duplicate keyword. Just have a look into it. So like search Biblo number. Which one was it? 178. So let's see. And there you go. We have, okay, the indicators are different, but we have a duplicate keyword for whatever definition you'll come up with for duplicate keywords. So we could also introduce the indicators so that when the indicators differ, it's not a duplicate, but in this case, just for the sake of the argument, I did it this way. But you can do, all the things that come to your mind easily now. Another thing which would be hard to do here is get referenced books. So we want to have all the books referenced by 440 and see what is the most referenced book here and which other books reference it. So again, we're just executing it. You'll find all those examples in the GitHub repo. So, and if somebody's going to use it, please, if you have interesting SQL, just give me a pull request, and I will add this example in this SQL folder here. So if somebody wants to have a look into it. So let's see, get referenced books. Yeah, Penguin Classics seems to be the most referenced book, which is referenced by those 6 Biblo numbers. Good fun trying to find this out in another way. So, another examples. We could have, we're going to have a look in the space requirements. Space requirements is just MySQL calculating the space. As you see, we come up with about, there we have 10 megabytes. Roughly 10 megabytes, including indexes. And our Fedder and Biblo metadata have about 5 megabytes in this case. This is a little bit misleading as the database is very small, so indexes are over-proportionally large in this case, I guess. So in a normal database, it's a little bit more than the original XML data files are going to need. Okay? So, but storage costs nothing nowadays. So, whatever comes to your mind and what your SQL skills will provide is going to work here, and quickly. So interlude 2, but Mark, this is everything I ever wanted. As I have dreamed of, and as I dream in SQL as you do, sadly, I want to print out the code and make love to it. Can this get any better? Yes, it can. So you can also write to it. So, yeah, modifying mark in bulk. It's a sad story because there are multiple approaches, and whenever there are multiple approaches to a problem, which means none of them is good. You could batch record modification. We all know this, which has, selection and processing are separated. You just have to create a target list before. You have to write some SQL, which gives you bibli numbers, and then you have to do the mark modification templates to modify this list, and it has a limit and everything. And the most annoying thing is that you can't modify indicators at the moment. I think somebody's working on this to modify indicators with the batch record modification. So every support company has developed some kind of meta language to modify large sets of records. I guess everybody has this. Just give me it, select the candidate numbers, and then create mark record from get mark record from the database, iterate through the records, and do some modification and stuff. So everybody has done this to different kinds of extents. So a short survey: are SQL views writable? Yes? Oh, no. Views are not writable. That's a common misconception. SQL views are writable. They're not very aptly named views, but in every database, it's doing a lot of SQL training. This is a question I always ask. Everybody says it's a view, so you can't write to it. You can write to the view. So let's have a look at it. So, as I've shown you, you can do the regexp. How's it called? ls regexp search pl, no such file or diary. Not pl SQL. So all the books containing Perl in their title. So search it like here. So you have those books. And what I want to do is I want to uppercase the word Perl in the title. So I'm just going to do this one. Hopefully this worked. Let's have a look. Def. So whenever we change either not the record table, the fields or the subfield tables, we have triggers on those tables which write to this change queue table so that the plugin is aware of what records have changed. So we can go back here, putting on the glasses. Administration. So, it's in tools. So we can check what update changed metadata would change. This is a job which finishes quickly here. Okay. A module has to be installed. So do this quickly. So if you want to use this this part, you have to install this one. Just to be sure, I'm restarting it. Jobs. Administration. Sorry for that. Okay. Now it's working. So we're using this semantic XML diff to see what has changed in our mark data. So we have changed new value CGI programming with Perl, whereas the old value was CGI programming with Perl in camel case or whatever you may like it, and that there are 10 different biblo numbers concerned. So update stored XML. So if you're looking for Perl now, we'll see that all the titles containing Perl, the Perl was converted to an uppercase, which is neat, I think, to say the least. Okay, this is working. Yeah, the change queue, as I've said, is filled with triggers. Okay. What my main issues are, and then we're nearing the end of this talk, is that XML, as such, is a transport format. So it's not something you should store it in the database, you should keep it, but for me, it shouldn't be the source of truth. You should parse it and work on the parsed version with. And if you want to export it, you should take the parsed version and recreate a new XML file. I'm not saying that this is something we should do immediately. It would be fairly easy to implement this in the Koha core because there are just 2 entry points. It's read get mark XML from database. So this, if you just put it there, it wouldn't mind whether it just grabs the blob and creates the record object from the blob, or it creates the record from there. So you can do any kind of slow migration. So I think it shouldn't be, but it is it like it is, and it's good like it is. But I think for future consideration, especially when we're going to BibFrame or something else, it would be nice if we could query that with SQL, because, yes, as I've said, I dream in SQL. Okay,